All right, Copper Canyon Algebra 2. So let's go ahead and look at some examples from 9.6. Like I said, not much calculation in these examples, really just a lot of remembering these, 5 transformations. And again, you won't use all 5 of them at once more than likely, but you know, there'll be 2 or 3 of them in a problem. So I think color coding is very helpful if you have highlighters or borrow some crayons from your little brother or sister. I think it'll definitely help. All right, so let's take a look at the first example right here. Describe the transformations, just keeping it short and sweet. So they're giving you a trig function here, but clearly there are things getting added. If it was just sine x, that would be it. That's the parent function, right? But they're adding all these things in there. So take a look at the first thing that's being added. There's nothing here in the front, so we don't have to worry about either one of these. But after sine, okay, you have something in here. Now notice that there's nothing in front of x. So technically we don't have a b here either, but we do have something getting added or subtracted to the inside. So I went ahead and highlighted this in green last time. So I'm going to take my green marker here and go ahead and continue with the color coding. And then we'll describe what that does. So here we go. So let's put a nice big green box around this part. Let's put a little arrow coming down. All right, so first off, think about what I mentioned last time. So this is controlling your horizontal shift. Okay, so I'm going to write, I'm actually going to write a couple things. Horizontal shift, remember they call that a phase shift. So I'm going to actually use a few words here because I'm not sure what your examples on Edgenuity will say. So we're going to use the trig word, but then also the word we're used to. So I would call this a horizontal shift. Okay, but remember horizontal shift is also a phase shift. So I'm going to actually put both words there. Again, what that means is it's making the graph move left or right. So let's talk about that left or right part now. So it is a plus. They're adding something to this. So go ahead and take a look up here. I went ahead and wrote a key. I fixed it a little from the last video. So if it's a horizontal shift, but they're adding something like they are in this one, they're adding pi over 4, that is actually causing the graph to move left. So describing this, this graph is going to move left pi over 4 units. So left pi over 4. Okay, so what that's doing is it's taking your waves and shifting all those waves to the left a certain amount, pi over 4 units. Okay, so that's one transformation description there. Sounds like a lot, but I'm telling you a little bit more extra here because I'm not sure what your examples will say for sure on your notes. Okay, let's take a look at the last part here. So we already dealt with the green part. That was the phase shift or the horizontal shift moving left or right. Let's take a look at this last piece. The last piece here controls your vertical shift. That's controlling your graph moving up or down. Okay, so let's go ahead and highlight that in purple. Again, I'm going to write a few words just because I'm not sure what they'll tell you, so look out for either one. You know, if I were describing it, I would just say, hey guys, this is a vertical shift. It's making it move up or down. So I'm going to say vert shift. Okay, but remember, in terms of vertical shift, this is also called the midline. So they might say something about the midline has shifted. So don't be afraid of that. So I'm going to just put in parentheses midline. All right, now let's talk about the direction. So it does say -3, and remember we're talking about it's moving up or down. If this says -3, I went ahead and wrote it on the last key. If it's going up, it would be plus, but if it's going down, it would be minus. So this clearly is a -3. That means this is shifting down 3 units. So the key word here is down. 3 units. They'll put units on the end of everything just because, remember, some of the units are measured in radians. Some of the units are measured in just regular numbers like 1 or 2. All right, and there's a quick description. Not a lot of work involved, but definitely knowing your parts. Color coding will help you. Again, I strongly advise you guys to color code. All right, let's take a look at a slightly harder one, a slightly more complicated one. And so this one, same thing, describe the transformations. So this time they're giving you more than just 2 transformations. And so let's take a quick look here. So again, the y equals, nothing big there, but then take a look. Here's cosine, but there's clearly something in front of cosine. So going back to our model here, this is really telling us this right here. This has to do with either a reflection or amplitude. I don't see any negatives here, so this must be our amplitude right here. So I'm going to go ahead and highlight that in red. All right, so that is our amplitude. Now remember, it's amplitude, but it also could be basically, it is amplitude, but you could also call it a vertical stretch or compression. So let's go ahead and do both again. So yeah, I would say vertical, Now let's think about this. Vertical stretching or compressing. You have to think about this number here, and we did it before in terms of $1, right? How much is this compared to $1? Is it more than $1 or less than $1? Because if it's more than $1, it's going to stretch the graph long ways. But if it's less than $1, it's going to compress your graph and make it look shorter and fatter. Technically, this is 75 cents. That's less than $1. So this is technically causing a vertical compression. Vertical comp, I don't want to write the whole word compression out. So we'll say vertical compression, that's your description, of 0.75. You don't even have to say it. But then this is also called your amplitude. Okay? So key thing here is that is a vertical compression because it's less than $1, and it's also called your amplitude. So again, either one. Key thing here is you cannot say stretch. This is clearly less than $1, so you've got to say compression. Okay, vertical compression, aka your amplitude. All right, so that was pretty easy for that part. So that takes care of this red part. The trig function on this one is cosine. Again, that's not that important yet until you get to graphing it. But after cosine, look, you run straight into a number. So now that 4 there is actually your B value. This is your frequency. And so now you do have to kind of worry a little bit about, okay, what do I need here and what is that really telling me? So let me highlight just the number 4. Notice I'm highlighting just the 4. This technically is your B value, okay? But remember, the B value is not really a transformation description. It's just telling you the frequency, how many cycles are there in that length of 2 pi. So what you're going to have to do here is you're going to have to actually calculate your period. So I've got some formulas here. Right above this, in fact. So if you're trying to find your period, you're going to have to take this little formula, 2 pi over b, and you're going to have to actually calculate your period. So let's go ahead and do that now. So to calculate your period, 2 pi over, and your b here is 4, so we're going to take it over 4. Now you might need to use your Desmos or calculator or something here if you're not good at reducing, but technically this is 2 over 4. 2 over 4 reduces to a half, right? So this is really going to be pi over 4. So this is pi over 4, or sorry, pi over 2, my bad. 2 over 4 is 1/2. So this is pi over 2. That is actually your period, okay? Now, this is a little tricky here, but they will call it your period. Your period is pi over 2. But what did it cause? Remember, period controls your horizontal stretching or your horizontal compression. So did it make this thing get long and stretched horizontally, or did it make this thing get compressed horizontally? So stop and think about the norm. Normally, a period for a cosine function is 2 pi. So you tell me, is pi over 2 smaller or is it less? Okay, so pi over 2 is definitely less than 2 pi. So this has caused a horizontal compression because it's made you have more inside of a cycle. So this is going to cause you a horizontal, that's the right word, horizontal compression. I'm just going to abbreviate hors comp. Because what this has done is it's caused you to have more cycles in a shorter amount of period because it squashed it and made it less of a period. Okay, so you're having your whole thing in a much smaller space because that's less than 2 pi. So if this comes out less than 2 pi, it's a compression. If it were to come out more than 2 pi, then they've stretched it. It's taking longer time to get there. All right, and then down to the last part. So we've already talked about amplitude, we talked about our period, and then this last part here, again, it's in parentheses. I keep doing this, it looks like a hamburger because it kind of helps you remember you're going side to side. But that's exactly what that part in parentheses is doing. This is your horizontal shift. Not stretch compression, but shift. It's making it move left or right. So let's do this one really quick. All right, so we'll highlight this. low right horizontal shift. And now let's think to ourselves, is this going to make it move left or right? So going back to our key here, that's a plus. So plus is going to make it move left. This is going left pi over 3 units. Okay? Sounds like a lot, not a lot of work involved, but definitely knowing your parts, knowing what controls what. So really write this model down, use some highlighters. I think it will definitely help you for this unit. Alrighty? See you on the next video, guys.